is an enormous task. Excavation teams spring into action in 16 quarries across the United Arab Emirates. The 11.5-kilometre breakwater needs a lot of rock. 5.5 million cubic meters of the stuff, enough to build 2 Egyptian pyramids. Rock is blasted out of the mountains night and day. Loaded onto dozens of lorries, it begins the arduous journey to the coast. Here, the rocks are immediately piled onto barges and shipped straight to the construction site. It takes less than 24 hours for each rock to travel from quarry to breakwater. 24/7, this floating conveyor belt delivers up to 40,000 tons of rock per day, nearly the same weight as 2 aircraft carriers. The density, size, strength and permeability of each boulder is crucial. This stone wall must last for centuries. There's no concrete or steel holding these rocks in place. These vast boulders are not just dumped in position, graded by size and weight, it's the sheer volume that keeps them here. Positioned by cranes, each rock must interlock with the next to withstand the full force of the sea. Constant checks are needed to ensure the breakwater is in the right place and the rocks are stable. The only sure way to do this is to send in divers to pinpoint and check every meter of it. Nothing about this megastructure is left to chance. Any movement could cause the rock to crack and the wall to disintegrate, leaving the whole project vulnerable. A detailed study of the breakwater rocks below the water is noted. Divers are looking for signs of fatigue on these 6-ton boulders. Their fear is that some will have splintered or been knocked out of place by strong waves when they were put here. Every 27 meters, a diver surfaces to record the location of the rocks they're checking. The reading is taken from a man based on land, but so far this section of the breakwater stands firm. January 2002. 6 months after work began, a large section of breakwater stands proud 4.5 kilometers out at sea. For everyone involved, it's an exciting time as the dream becomes reality.
When the first breakwater came up, of course, we all went out there. We had to stand on it. This tiny little precipice of rock in the middle of the ocean, and look back at Dubai and say that this is the beginnings of our job.
It's a momentous achievement for the team, but there's still over 10 kilometers of this vast sea wall to build. The engineers are jubilant, but their happiness is short-lived. Winter is closing in. With a schedule of only 2 years to complete the breakwater, the last thing anyone needs is a delay. Winter in the Middle East brings shamals, great storms with winds of up to 56 kilometers per hour. Wind shifts are sudden, whipping up the sea, bringing torrential rain, violent thunderstorms, or blinding dust storms. On land, little can move. Out at sea, things are even worse. Massive waves batter the boats that need dead calm water to place the sand and rock with pinpoint accuracy.
We had to seek shelter in the very little shelter that we had built.
Engineers planned for the bad weather, but the storms of March 2002 are worse than they feared.
Everybody crowding around trying to protect themselves from the storms.
The boats find shelter, but more worryingly, will the breakwater hold? It's a nail-biting time. Over the next 3 weeks, the storms are relentless. All the engineers can do is watch and wait. The breakwater stands firm, but the schedule is slipping. The construction team is 3 weeks behind, and the pressure is immense. Every second counts. It's vital that the fragile sand island has protection. Only when a 550-meter-long section of breakwater is built can the Palm Island begin to rise above the sea. But the schedule is desperately tight. The entire megastructure must be complete by 2006. They have 2.5 years to create the island and breakwater, and just 2 years to build the city on it. The only way to meet the deadline is for both the breakwater and the island to be built at the same time. It's not an ideal situation. It will mean that throughout the build, the Palm Island will have the bare minimum of protection from the sea. But the engineers have no choice. The deadline is set. While the second team, building the island, wait for the protective breakwater to be built, they keep ahead of schedule by laying the sand foundations below sea level. But now, 8 months after construction began, they are desperate to break the surface. Finally, April 2002, the first 550-meter section of the breakwater rises 3 meters above the sea. At last, the builders of the Palm can step up the action and bring the island above sea level for the first time. To complete this massive island, Team 2 has the awesome task of finding 94 million cubic meters of sand to create their island, enough to cover the whole of Manhattan 1 meter deep. It's an enormous job in itself, but finding the right sand is an added headache. Dubai has more sand than it could ever need, but there's a problem. Desert sand is the wrong material for the job. It's too fine. The particles won't cling together. It means that the vast sand island would simply wash away. The engineers must look elsewhere. The best sand for the job is found 6 nautical miles out at sea. This sand is much more suitable. It's coarse, packs densely, and is more resistant to wave impact. They will dredge sand from the Gulf seabed. And there is an added benefit. The dredgers will spend less time transporting the material to the construction site. In just 3 hours, a dredger travels to and from the site, scoops up the sand, and sprays it into position. It works a 5 square kilometer area, dredging up the top meter of the sea floor. It takes less than an hour to fill the 8,000-ton tank with sand. The sand is then pumped through a pipe and sprayed into place at 10 meters per second, enough to fill an Olympic swimming pool in 4 minutes. The process is called rainbowing. The island construction team work round the clock to keep to the tight schedule. Night and day, the island grows bit by bit. The rainbowed sand builds into a sandbar, rising up to 4 meters out of the water. But for the engineers, there are mixed feelings. Is the shape of the island progressing as planned?
There's great excitement, and there was great anticipation, and a little bit of fear. Is it in the right place?
With doubt cast over the construction, Dubai has a trick up its sleeve. 676 kilometers up in space. Dubai has access to the only privately owned satellite in the world. It's so powerful, it rivals those of the Russian and US military. The satellite, IKONOS, orbits the Earth, taking pictures that prove the island is totally on track, so far. It also means the Crown Prince can keep a close eye on his pet project. August 2002, a year in, and the island team is ahead of schedule. 8 kilometers of the breakwater stands firm. 8 palm fronds break through the azure seas. But it's a grueling and difficult process. Rainbowing is a common operation in land reclamation. But this is no ordinary reclamation project. There is no mold for the palm shape and no fixed points to get bearings from. The unique shape makes it a nightmare to build, because the whole design relies on accuracy. This enormous structure has 56 kilometers of waterfront, and almost all of it is curved. To make things more difficult, it's impossible to tell from the ground if the sand is falling in the right place. The only way to complete this task is to use state-of-the-art technology.
Prior to GPS, we couldn't have done this job. There are only 2 straight lines in this project. All the rest of them are curved.
It's all down to a team of 5 men who walk the perimeter of the island every day as it takes shape. It's grueling work. Summer temperatures reach a searing 48 degrees Celsius. Humidity hits 95%. With heavy packs strapped to their backs, these mobile receivers create a grid reference for the island. Receiving signals from space and a fixed position on land, the height and position of the sandbars is recorded. With these coordinates, dredgers can sail into the exact position and rainbow the sand with pinpoint accuracy. Only by using state-of-the-art GPS technology can this awesome megastructure take shape. As the world watches, the Palm Island becomes a reality. At the same time, faith in this tiny emirate is restored. Post 9/11, Dubai emerges as a safe haven in the Middle East. The beaches fill up again. Business resumes. The Crown Prince's gamble to continue construction has paid off. But there is still a deadline to meet. The island must be built by 2006. Coordination between the two teams, one building the breakwater and the other reclaiming the sand island, is crucial. If they don't work in perfect synchronicity, the whole project could be thrown into jeopardy.
If the breakwater progressed too quickly, it would cut off access for the reclamation contractor. If the reclamation went too quickly, then it would be at risk for the storms. We couldn't let one get ahead of the other in any way.
It's a delicate balance, but a year into the project, and incredibly, work is on schedule. Against all odds, the Palm Island rises above the waves, protected by the ever-increasing sea wall. It's a symbol of engineering achievement.